Recording in progress.
Good afternoon, everyone, to today's workshop, today's webinar, that is External Facade in Revit. So, my name is Prakriti Goel, and I'm working in Capricorn as BIM Specialist Architecture. So, I'll be hosting the today's webinar. Now, first of all, let's discuss the today's agenda. So, first of all, we will be having a brief introduction about our company, and then the design advance brief will be done by yeah. So, Kanchan, yes. So after that, we will be diving into how external facades will be developed in Revit, right? So now let's discuss about our company. So Arkans in Private Limited is actually India's leading design and construction technology solution provide uh, like uh, the provider of architecture, engineering, construction, and manufacturing industry. Our main vision is like we deploy data-driven solutions across the construction and manufacturing sectors worldwide to improve sustainable projects design, construction, manufacturing from concept to operation. Yes, since 1987 to 20,000 plus Indian customers and 200 plus tech savvy team and to like yeah. So to Arcans, the way we work, so through our partner to build a smarter strategy, we are delving into delivering a portfolio of solutions to help customers design, build, and solve from tomorrow's challenges. So we are like all over the world. We have we have divided into three parts: Americas, EMEA, and APAC. Now, as an unmanaged global service platform, we are the world's largest provider of the Autodesk software and professional service to the construction and manufacturing sectors. We have 50 plus offices around the world, and we are located in 18 plus countries. Right now, let's talk about design advance 2024. So we have Kanchan from Ethos. Kanchan, are you there?
Yes,
Yes.
hi.
So
Thank
over
you,
to you,
Prakriti.
Kanchan.
Yeah, I'll be sharing my screen. Hi, everyone. I am Kanchan from Ethos Empowers, and I'm leading the competition at Ethos Empowers. So I'll just take you quickly through a briefing. So the theme this year for Design Advance is Architecture of Assembly, Industrialized Construction for High-Rise Buildings. So clearly, we are dealing with industrialized construction with the prefabricated components, and we are assembling a building like it's the introduction of a new or a rather newer kind of a construction technology for students. So we'll be discussing the theme, the design task, the guidelines for participation, and some frequently asked questions. So there are two aspects to this theme. First, we want to revolutionize the construction process of multi-storied buildings, particularly using prefabricated components through industrialized construction. And why we want to do it is because we want to navigate the challenges of unorganized labor, workmanship issues, site management, pollution caused by construction, etc. So what these issues do is they kind of make the construction process inefficient, and they cause delays and poor quality of construction. A lot of issues these can cause. Moving on, why are we looking at residences or particularly residential high rises? Okay, so you must have observed like there are repeating elements at identical layouts of units in multi-storied apartments, or like they're just same units stacked over each other. So the staircases, or be it railings, or facade, or the balconies, or the toilets, they are mostly the same unit that is being used everywhere on top of each other. But due to the scale of the entire project, say it's a 10-story apartment building, so it will take a long time for it to be constructed and to be occupied if we go through the traditional construction process, right? So how can we save time, effort, expenses, and resources while designing these buildings? What can we do to somehow standardize these elements? And what if we can produce them in a factory? What if we didn't use, what if we didn't need to make them on site, and like, what if they could be produced at once in a factory, brought to site, and just assembled? So we are heading exactly towards that. So in prefabricated construction, only the base or the foundation would be laid through the conventional methods of construction, and the superstructure component, be it walls, floors, doors, windows, facade, railings, entire toilets or kitchenettes, balconies, these can be produced in a factory and later assembled on a site. So the first part of the process would be to standardize these elements, like how big or small these elements are going to be. You're going to design them on BIM softwares and whatever your requirements are. And these elements are going to be produced in a factory in whatever number that you require. Once they are produced, they will be moved together to the site. So a lot of to and fro of construction parts and construction materials, that is also saved if you're fabricating elements in a factory. And then when they are assembled on site, you just have a, like, you're just putting walls together and you're just putting windows together instead of the artisans or the workers making them on site. So what can be prefabricated? Building systems like fire stairs, elevators, plumbing, these can all be prefabricated. Complex systems like facades, which you're going to learn today, they can be prefabricated for accuracy and like quality control sort of. Then the components like walls, floor panels, doors and windows, toilets, kitchenettes, these can be also prefabricated. So we are quickly going to look through a case study. This is called 10 Degrees, 108 George Street in London, UK, and it is designed by HTA Design. So you can see like there's this sort of repeating facade that is going on here, and it is composed of these diamond-shaped elements. So this part is the facade, and you can see there's a small Juliet balcony peeking through. And this is how it all comes together, right? You can see the system, how it is being attached. And here is a configuration of these modules, and you can see in this figure ground, like how these, or like how many of each module are being put in a single floor. So you've got these four here, uh, two here, something like that. Okay. So this kind of a configuration is going on, and you can figure it all out on your BIM software, right? And then you give those configurations to the factory and they will be produced there. So what it did for this project was from the project timeline shrunk, and it was like from the first concept sketch to the handover of the building, it only took 39 months. 67% of carbon emission could be reduced compared to traditional construction, and there was a significant reduction in waste and better quality control. And how did they do it? They extensively used virtual reality and 3D printing. So that allowed them to rapidly prototype all these elements and figure out what they can do and what will work, what will not work at the planning stage. And the prefabricated components, they were manufactured offsite and they were assembled later on top of each other at the site. A similar case study of these apartments, the Koekerijs apartments in Utrecht, Netherlands. So kitchen, bathroom, stairs, facade, they were all prefabricated and just placed or assembled there on site. It's a very highly standardized and rationalized project. You can also look it up. We come to the task. So you design a high-rise residential building or building complex using industrialized construction with the prefabricated building components. And just give me a moment. So you design a high-rise residential building or a building complex using industrialized construction with prefabricated building components. So what you'll have to do is understand industrialized construction and prefabrication of building components to create sustainable, inclusive, and accessible spaces. So, and you explore the suitable construction materials, right? Then you demonstrate how a transition from unorganized or the traditional construction methods to a more organized construction practice, which involves industrialized construction, will address the issues of quality, the workers' protection, and sustainable design. Here are the guidelines for participation. You choose an urban site, ideally in a tier 1 or tier 2 city, with the following guidelines. The site area should be between 5 to 12 acres, and the minimum FAR that you're trying to achieve should be 3. And at least ensure there is 15% green cover in the total site area. Follow the local bylaws or the national building code in case the local bylaws are not available to you. One more thing, it is a very essential part of the guidelines that at least 50% of your design should be constructed using IC prefabricated building components, partially or entirely. And you can show these details on 1 to 2 sheets, highlighting the prefabricated components and which elements you've chosen to use and why you've chosen them. Here are the design considerations, how well you've integrated industrialized construction, in-depth research and application of industrialized construction, the how sustainable your design is, and if well-being is ensured in your design, that is a very important part of it. And basically, feel free to unleash your creativity, right? Uh, the registrations will close on October 7th, so make sure you register for the competition before that if you haven't already, and the submissions are open until October 17th. It's open to all undergraduate and postgraduate students of architecture, planning, civil engineering, and design globally. And those graduating or those who have graduated in 2024, they are also eligible to participate in this competition, and maximum 3 members per team are allowed. Here are some frequently asked questions that we get regarding the competition. Is there a registration fee involved for the competition or the workshops? So no, there is no registration fee at all. It is completely free. The postgraduate students can also take part, like we discussed on the previous slide. Can the team members be from different colleges? Yes, inter-college teams and inter-batch teams are allowed. In absence of local bylaws, which standards should we use? NBC is to be followed in absence of locally applicable bylaws. And you can choose a site on your own. Absolutely. Just ensure that it's in an urban site and it's a tier 1 or tier 2 city with 5 to 12 acres of area. Then can we define our area programs? Yes, we would encourage developing your own area program and for the functions and distribution of spaces allotted to each function as per your requirements. Correct? Lastly, we come to the end. So you can register yourself at www.designadvance.in, or you can simply scan this QR code if you're trying to register. That's it for today. Thank you so much.
Of the like one of the example the Kanchan has provided you during design advance brief, so you can actually see like repetitive facade module will be used for developing your facade. So it can be a simple rectangular facade, it can be like complex facades, right? It can be like shading devices, right? So whatever facade you want to provide in your project, right, in your like high rise buildings, in your maybe like uh what we can say like in industrial construction buildings, right? So again, like that facade will be repetitive, right? You will be creating a module, right? So if I talk about the facade, so facade is actually a very much important part of a any building, right? So its aestheticity and its like complexity, its like appearance will be uh, judged by the facade, right? So again, the facade of the building is actually very much important. So if you are designing the facade of the building, how it will be beneficial if you are developing in Revit. So first of all, if I talk about how BIM actually helps in facade development, so again, there's a concept of adaptive family in Revit. Now, what is the adaptive family means? So a family, Revit like component, which will adapt according to the like different circumstances. So if I show you one example, so let's say if you are developing these kind of facades, so yeah. So these are the repetitive modules, like one you are creating and that will be repetitive, right? Or like that's up to your design. That's completely up to design. So you can see these are the facades that can be possible through different like design. So yeah, this was the example that was like Kanchan was giving, right? So this kind of facade you can easily develop through Revit. Now how? How? That is the question. So if I talk about like a concept called adaptive family, so that family will be adapting according to the situations. Now same like right now you can see that this panel like the panel, the HTA design build, like you can see the facade is actually used for straight buildings. But same facade can be used for curved buildings as well. But you have to use adaptive for that, right? So adaptive means if you are developing any complex structure, any complex building, same facade can be used for that complex structure or from like for straight buildings. As well as you can provide these kind of designs like where we have protruded windows, or maybe we can say like some of the detailed designs, like if you have hexagonal patterns, hexagonal curtain panels, right? So these are can be these every like facade actually is possible. So right now we will be delving into how we can create these type of external facades in Revit. What is the like preferable method for developing the external facades? So like the preferable method is like going for the adaptive family, so that like if you are going for the conceptual design, you are developing the conceptual form using mass, the massing environment, the conception mass environment of the Revit. And then after that you are developing its facade, so you will be using the family, the parametric family. So parametric family means like we can change its sizes and all. So we can change the panel size, we can change its material and all. And that family, that panel should be applicable for any circumstances. Like if you have a curved building, if you have straight buildings, right? So now let's go for the adaptive family. Like what is the family? So like create like components which are flexibly adapting to the certain circumstances, like unique conceptual conditions. So it will be flexibly adapting it, right? And adaptive components are an adaptation to the pattern base. So like again, if you see any facade, there certain pattern is flowing over here. So over here you can see the triangular pattern is actually visible, right? So it is actually applicable to the patterns only, to the pattern of the facade. Like you can see over here, if you are developing this kind of like facade, so it is actually hexagonal, right? And let's say if I talk about for this, so it is actually rectangular pattern, right? So it works using the patterns of the like facade, right? So yeah, now let's talk about the concept, like how we can actually create that. So first of all, this adaptive family is actually like based upon points. So point is actually very much important for creating these adaptive families. Those points are only the adaptive. Like if you move those points, your geometry will also get moved, right? So that those points will make that family adaptive. So we'll see in the demo session. So okay, but where we should use, like why we are using it. So again, the external facades. Now, if I talk about facades, facades are actually very much important in terms of like if you're going for the climate responsive architecture, right? If you are developing, let's say if you are developing industrial construction, so in what climate it is actually like, in what climate it should like basically it should be climate responsive or sustainable, right? So that facade actually is very important in that case. So let's take the examples from the real context, like how we can actually develop these facades and why these facades are actually important. So let's take an example of Kaifer Technique showroom, which is in the Austria. So you can see the concept of this like whole panel was just like protecting the inner interiors with these like direct sunlight, direct like solar heat. And whenever there's a sunlight, it actually expands, like it will be closing. So if I show you one example, like how these panels actually work. So you can see whenever there's sunlight, like you can see how they will expand. It will not completely close, but it will just like close at certain limits so that sunlight will not enter. So this mechanism is actually controlled by computers, which is actually calculating the sunlight like sun path direction. And according to that, wherever there's a direct sun here, like direct sunlight, the panel will expand. So you can see. So these are like there are motors which is actually helping that like the shading devices to open and close, and the computer within that it is actually calculating, right? Next, if I talk about a different tower, that is Al Baha Tower in Abu Dhabi. Again, it has a concept over like Mashrabia. So it is actually a concept of like a wooden lattice shading screen. And according to that, like they have actually developed a concept like how the form has been created. So it is actually like high-rise building. Again, they have used certain integration over here. So they have created PTFE panels. PTFE panels, like which is actually open. Like you can see how they have incorporated the concept called Mashrabia, right? So if I talk about like the working, so you can see they will open and close as per the sunlight, and this will be like an umbrella system. Like you can see how the panels are actually acting as these shading devices, right? So again, it is actually calculated by the computer only, right? So not only just for showcase, but you are actually developing the facades according to the like like for sustainable development or maybe for climate responsive uh, projects, like climate responsive buildings, right? So we will be delving into how we can actually develop these effects, like these uh, panels using sunpa direction. So our motive is like we need functional facades, right? So let's get into how we can actually develop the facade over here in Revit, and how we can actually use, like how we can actually like make that facade like climate responsive by changing when the sun path is also changing, right? So let's first discuss about that. So I am taking the example of the Kaifa Technique showroom. So Kaifa Technique showroom is just like this. So you can see how like over here we have two, like we have one panel, and in that one panel we have like two small panels which is actually expanding and contracting according to the sun path, right? So we will be developing that. So in this case I'll be using, so I'll be using the adaptive family over here. So we have different type of like different type of templates using that. So for adaptive family, a separate template is there. So let me open that. So you can see over here we have generic model adaptive, which is just like simple model, but we need a pattern. Like our full facade will be divided into pattern, like rectangular, maybe hexagonal. So as you can see, according to the different examples, right? So right, so all the like the facade will be divided into different pattern, and then we will be placing the panels, right? So for that I'll be using a certain template, a specific template for that, which is metric curtain panel pattern based. The unique, the uniqueness of this pattern, like family template, is actually this. This is called the pattern. It can be changed into various patterns, like say octagonal and all, like different type of patterns, rhomboid and all. And you can see these points are actually adaptive points. These points are actually adaptive. How? If I move any point, let's say if I move any point, you can see the geometry. The lines that you can see over here are actually moving on according to the point, right? So when we place this panel in any curved surface, so they will be adapting according to these points. So when the points move, the geometry will also get moved, right? So now let's talk an example of the Kaifa Technique showroom, how it is, like how it will help. So first of all, I need to change the panel size. So let's do that. Now, as per like over here, you can see this is one glass panel. So over here, you can see in the like example. So one over here we have one glass panel, and over glass panel we have two panels, two separate like panels. So which will be closing and opening according to the sun path, right? So both panels will be creating in the same family. So right. So let's see how. So again, it will be parametric. Parametric in the sense like so that we can anytime open and close the panels according to the sun path direction. Right. So let's create it. So right now this is like full panel and we need to divide it. So I'll create a parameter. I'm, I'll be creating it. Right. So let's give it a parameter. Let's say this will be a total panel height, which will be used like because we don't know the panel height in the project, like we don't know this, but we need this as a formula. That is why we are using as a reporting parameter. Now we will be dividing this whole single panel into two so that we can like provide both the panels over here, right? So I'll be creating over here. the opening of the panel. So this panel will be opening like this. So it's just like an umbrella. So when the opening will shift to this side, the the panels will open, right? Like the panels will be open in, like, they will contract, right? So it's like that, right? So we need to provide a parameter for the panel contraction and expansion basically. So okay, so like right. So yeah, so what you can do now, I'll be providing parameters to it. So this will be changed, right? And it should be in the opposite direction of this point. Right. So what we can do, we can try this, and if let's see if it's working or not. Yeah, it is working. Same, we have to do it over here. Okay, now we have done this. So like these will be the uh two panel ends over here. So like over here, yeah. So these, let's say, like because this is your rectangular panel, so let's assume that like we have divided the like whole rectangular panel into three parts, like into maybe two parts for these rectangular panels, right? Now like I'll be creating the, like over here, the panel geometry. The altitude, because over here, once your uh like panel will open, like once the panel will fully contract, like over here, when it fully contract, it will create a 90-degree, right? It will create a like altitude, right? So according to that, the altitude angle will get like increase, like will increase and decrease according to the panel opening. So this angle we need to adjust, right? So I'm placing the, like, I'm creating the altitude. And giving it certain height. So let's say 1200. So yeah, so we will be providing its height over here. So let's say this will be panel height. And then I'll be providing its formula so that the panel height, the one that we are giving for the altitude, should be like divided by 4, like should be uh what we can say, it should be 4 times, like 4, like the total panel height should be 4 times of the altitude. So that is why. So we have provided over here the panel height. So you can see automatically it has been adjusted. Right. Now what we need to provide certain like, again we are creating the panel geometry over here. And now, like over here, this will be the center position. This should be half of the, like, it should be half. So again, we are creating the parametric family because again, it will be changed according to the, like you are creating one module and it will be repeated, and your panel will work according to the sunpa direction. That is why we are creating the parametric family. So again, this will be according to your, like, this will adapt according to the situation. So that was why we also, like, that is the reason of for which we are developing the parametric. So we are locking it so that, like, the position of the altitude center will be at the same location. Right. Now we will be creating the geometry. So because it should be just like an umbrella structure. So like again, it will expand and contract according to that. So if I show you the video again, so it will look like this. So you can see like this, right? So we are developing the exactly same over here. So once this point actually moves, the panel depends upon this. Like you can see, this is what actually depends how the panel will work. But it should be in the opposite. It should be like once the like opening is like once the contraction happens, so the panel length like over here, this should mm, decrease and the height of the altitude should increase, right? It's actually inversely proportion, right? So I need to go for the opposite direction. So you can see, so let's provide the parameter to it, which will be equal to the opening. Yeah. So let's say your opening is maybe 75, maybe 50. Point. So you can see the panel height has increased. Like the panel height is actually short. If I talk about let's say 0.25, like 25 or 25% of the panel should open, or maybe 30%. So yeah, or maybe 15%, like or maybe 10%. So yeah, the panel height is increasing. The like the distance of the panel, like this opening, the contraction is actually understandable, right? So we will be creating as per this, like we will be creating the geometry as per this, like this. So if I change like if I change the panel opening to maybe 4.5, so you can see. So right now I'm just providing manual parameters, like I'm just changing manually. So can it be done automatically? Yes. So let's see how. So for you, I have already developed it. So let me open that. So again, this is the panel, right? Now if I change this panel size, so over here we have created a the closing percentage, a dummy parameter which is not aligned to anyone. And like over here we have created, like we have provided a formula so that right now it is actually like we can say in like it is actually the opening value is actually like what we can say. Yeah, just give me a minute. Yeah. So it is actually normalized curve parameter, which is actually the range from 0 to 1. So it is like 0 for 0% and 1 for like 100%. So 1 is the maximum and 0 is like minimum value. So over here, it means like if I talk about 50%, so 50 divided by 100. So it's just like that. So normalized curve parameter is that, right? Now we are actually using a dummy parameter closing percentage. So if we provide a percentage over here, let's say my like panels will be closed maybe like for 25%. So according to that, the opening parameter, the opening of the panels will work. Right? So let's see. So yeah, it is working. Right? Now you can apply it to the to the facade. So in this case, I'll be using a conception mask. So for you guys, like I have developed it uh, over here. So let me open that. So this is how your panel will look. Like if I suppose select a panel, if I suppose let's select the panel over here, I can change the percentage over here. So it is right now 80%. But if I want to change it, let's say maybe 25%. So because it's the instance parameter. So that is why you can see key only one element is actually changed. And it is done by manually. Like we are doing it manually. But if I want to change the panel opening according to the sunpa direction, so in that case I need automations. So automation will be done through Dynamo. So that will be called as dynamic facades. So basically this whole external facade, we are going for the functional external facades. So like which will be controlled by the computers and electrical motors according to like the computer will uh, like it will actually calculate the sunpa direction as, and then the panel will work, right? The panel will contract or expand. So it's like that. So for you guys, I have already created the script. So I'll be going for the manage. So I'll be opening that script. So once you like first like for few days, like if you are opening Dynamo for like for uh longer, like after long time, so that is why it takes time. So yeah, let me open that script. So this is the whole script that we will be using. And first of all, we have to enable the Sanpa direction. So this is actually the mass family. So like by default over here, we don't have the Sanpa direction of like on and off like option over here in the view control bar. So we have to go to the properties of 3D view from here, and then we have to turn on the sun path, right? And then if I run the script, let's run the script. So I'll go for manual first. So you can see if I move the sun path over, if I move the sun direction, you can see the panel will panel will work according to that only. So I'll show you again. So if I turn on the shadows as well, so you will understand what will happen. Like, so let me turn on the shadows. Yeah. So you can see half of the panel according to the sun power direction, it is actually calculating the sun power direction. And according to that, the panel is actually closing and opening according to the direction. Yeah, you can see. So where we have less amount of sunlight, so the panel will contract. But if wherever we have direct sunlight, maximum sunlight, so the panels will expand. So like you can see how this will whole process will work. So this is actually called dynamic facades, where we are using dynamo for automation, like calculating the sun power direction according to the location, and the panel will work automatically. Right. Next, according to the like Albaha Tower. So yes. So again, like same aspect. Like if you are developing that facade, if you are developing that facade, first you have to create the adaptive family and use the Dynamo for the automations. So let's see in this case as well. So let me open Dynamo first. Meanwhile, if you have any questions, you can provide that question, like provide in the Q&A chat box if you have any questions. Because after this, we'll have a Q&A session. So I have provided over here, like we have already created the scripts like for this as well. So you can see. So if I like run it, so according to the sun power direction, this whole facade will work. So what I'll do, I'll click for the timing. I'll go for automatic because once I change the sun path, the facade will change. So we have to, we want to, we have to see that, right? So just see over here. Yeah, you can see it is working. Right? Like this. You can see these are almost getting closed. right? So this is how you can actually develop your dynamic facades using the like Revit, as well as for automation we can use Dynamo. Now let's have a Q&A sessions. So okay, so if you have the query regarding like we offer uh, our courses as well. So we have a BIM for design course in which we all like we which in which we discuss everything that is actually discussed over here. So in detail, if you want to know, so you can actually contact connect at capricorn.com, right? And over here again, like yes, you can enroll to that session, and in that we'll discuss everything in detail. So first of all, you need to develop the scripts. So I think someone has asked how to apply Dynamo functions for facade. So over here, you just need to create the script, and once you like run the script, so automatically that facade the facade will work according to the sunpa direction. But the main thing is like the function, the script that you need to develop. So Dynamo is actually visual programming tool, right, for computational design. So like where are actually taking design related decisions using the help of computer language. So it is actually visual programming tool. So right, so for that, like if you want to know about that in detail, so you can just enroll to our BIM for design course, right? Any more questions you want to discuss? Any more questions, if you have, you can just provide them in the Q&A chat box. I think um I think that's it. So if you have any more questions, you can just provide them in the Capricorn at like connect at capricorn.com, right? So I think that's it for today's session, right? Thank you all for joining, right? Thank you. So let's end this session and this webinar over here. Okay. Thank you guys for joining.